This last thing was distortion.
What?
Distortion. Last thing
Distortion.
we took, yeah, Tuesday.
Okay.
The
But you
Sunday
didn't
was
study modulation at
an
all.
introduction just in the beginning of chapter 1.
Okay, so do you know what is modulation, right? Okay, you just send your message signal with the carrier frequency so that the information is not lost. Okay, double sideband, I will give an overview. So go to the Moodle and download lab 4 examples.
Hello, Miss. How are you?
Hello, how are you? I'm fine. How are you? So go to the Moodle and go here, lab work. Download this one, lab 4 examples. I think I didn't share my screen. Okay. So go to the Moodle and download this file, lab 4 examples. Okay. So anyone else is coming? Should I turn this light off? Is this okay now? Fine. Not good. You will sleep. Should I make it bright again? So I just did it for this. That's nice. You will sleep. Okay? Which is better? This is better? Yeah, it's better. Yeah. Don't sleep. So okay, I just wait for it. I think I'm watching it going. So in this lecture we will study about modulation, amplitude modulation. So all of you have you already know what is modulation? So normally you have one signal. For example, your signal is like this, and then you multiply it with a carrier frequency, and then you transmit it. Why you do this? Because if you just transmit your actual signal directly, then this signal will be distorted or it will be lost. Information will be lost. So you will multiply with this. You will then you will transmit. Okay. Then the information will not be lost. Okay. And then when you will receive the signal, then you will do the demodulation, and then you will get your actual information. So there are two types of modulation. One is frequency modulation, and other is amplitude. So what happens in frequency modulation? The frequency of the carrier wave is changed like this. Frequency is changed. In case of amplitude modulation, with respect to the message signal. With respect to the message signal. In this, the amplitude changes. The amplitude of the carrier changes. Okay? In amplitude modulation. Okay? So, what is double sideband pressed carrier? For example, you send your signal. Okay? For example, this is your message signal, message, and then this is your carrier. This is your carrier, okay? Then you will multiply it. This is double sideband suppressed carrier is a type of amplitude modulation, okay? So what will happen? This amplitude will change, then like this. This is in time domain. In frequency domain, you will get the information is like this. In case of bands, and this is your carrier. This is frequency analysis. This is time analysis. This is frequency analysis. Okay. Now what happens in this double sideband suppressed carrier? You get the bands, but then carrier is suppressed. There is no carrier at the output. What is the benefit of not receiving the carrier? All the power loss or dissipation will not occur, and all that power is used for the message signal. Okay, at the output you will get two bands, and your all the information is in these two bands. Okay, in frequency domains. So this is a double sideband suppressed carrier. So this is your message signal. This is your carrier signal, and you see this is amplitude modulation. The amplitude of carrier wave is changed with respect to the message signal. So you see, as this is moving, so this is like this, same that input signal, like same, yeah, same. But the amplitude of the carrier is changed, okay, with respect to the message signal. So in this lab today, we will generate an amplitude modulated signal, double sideband suppressed carrier. We will generate it. So first we will generate a modulated signal. What is modulated signal? This is the message. Yes.
Yeah,
Message. Yeah. Message signal is also known as modulated signal. Then we will generate carrier signal, and then we will receive that. So this is for your revision. So you already know that Frequency is the reciprocal of time. Frequency is the inverse of time. Okay. And then what is angular frequency? Omega is equal to 2 pi f. This is from the previous. So what is here? You remember we were doing the time scaling. We were defining the scale here. In this is our start value, this is our increment, and this is our final value. This is the number of cycles we want in the output, and this is the frequency of the message signal. See, this is 0, starts at 0, this is starting value. So this is the increment time, sampling. So this is sampling time. Ts is equals to 1 over fs. So sampling time is 2 divided by fs, and then 4 is the number of cycles, and m is the frequency of the message. This is our final value.
Miss,
Yes.
this is formula.
No, this is not formula. This is the time scale.
So the number can be changed, this number.
Yes, you can change, but this sampling frequency will be given in the question.
Okay. And then 4 and 1 and 0 will change. We can change.
Yes, this message signal will also be given in the question.
Okay.
You have to define the time scale length. Okay. So that you get actual sampling frequency, you get actual frequency of the message signal. Okay. You cannot randomly select these values. You should select these values according to the question. Okay. So now, for example, I have a vector. This is revision from your MATLAB. So you have a vector which has values from 1 to 9. Okay. If you write in MATLAB length of y, it will give you the total length of the y. How many elements in the y? 9. So this, in the previous lab also I told you. So length space of 9, 81 mm. It means that this is the first point, this is the second point, and then this should be the total length of the samples. Okay. In MATLAB, what happens is, for example, this is x2, this is x1, and then this is n, number of samples. So what MATLAB will do, x2 minus x1 divided by n minus 1. In this case, x2 is 81 minus 9 divided by L is 9 minus 1. And this is 72 divided by 8. 9. So this will distribute this according to these number of samples. Okay, so 9 samples. So it will start from 9, first value. It will end at the final value, and then in between a difference of 9. Okay. So returns the length of a vector. This defines a vector. How you want your vector to be spaced. This is last value, and then this is the number of values. So you know that whenever you write a sinusoidal function, you write its amplitude and angular frequency. Okay, this is from the previous, and then this omega naught is equal to 2 pi. So what does this command do in MATLAB? MATLAB P of x. If you have a signal x in time domain, and then the signal is discrete signal. Okay. F of t of x gives you the Fourier transform of that signal. Okay. Discrete Fourier transform. And then if you have this is the n point DFT. So how many points you can define here? Okay. And then this will normalize your frequency response with any constant. This can be any value from 1 to up to so on. Okay, any number. Then FFT shift. Also, I told you in the previous class, it will scale this zero frequency component center of the array, the center of the scale. Okay, so one spectrum will be here, one will be here. This will be equal distribution. And the zero frequency component will be exactly at 0. Then this also I explained in the previous class. So this is a complex number, right? 3 plus 4i complex. So if I get absolute of c, what it does?
Square root of three
Square root of,
plus
yes, 3 square plus 4 square, so answer will be 5. So MATLAB does all that calculations behind and then give you the result.
Miss,
So now if you write FFT of your actual signal with n number of samples, normalized with the number of samples points, then take FFT shift and then take absolute values. This will give you the frequency response of your signal.
Miss,
Yes.
my laptop is shut down suddenly. Can you repeat what you said?
From where should I?
Previous page.
Here.
Eh,
So I was just explaining to them that FFT will take the Fourier transform of your actual signal. Okay. If you have time domain signal, if you take
signal X, right?
X is time domain signal, any signal, maybe X is equals to cosine of T.
Okay. And FFT is the Fourier transform.
Yes, Fourier transform of this signal. Okay. You will write.
And what? The second one, X capital and N small. What is this?
N is this one, this cosine, this function, and N is the total number of samples. How many
Okay.
samples? And then this one, this is same, and this is, you will normalize your x's with respect to this. This can be any number. 1, 2, 3, any number.
Okay.
In the next here, we are normalizing this with the actual number of samples, actual number of points. So this one, FFT shift in the previous class also I told you that what it will do is it will shift the zero frequency component in the center of the array. Exactly in the center of the array. So one spectrum will be here, the second will be here, and zero frequency will be here. So this will take the absolute value. This will remove this complex number from your pixel. Okay, only the absolute values. So you know that this is equal to square root of 3 square plus 4 square. So answer will be 5. Right?
Which one will move the complex, the shift?
Abs.
The ups. Okay.
Abs of C. This will only give you the absolute value, amplitude. Amplitude of this C signal. Okay.
And the shift make it hit to 2 halves, right?
Yes, the shift will make it 2 but across exactly at the center point.
Okay.
Exactly. It cannot always be 0. It can be any point in the center. Okay.
It make the Fourier transform, right? This the middle.
No, Fourier transform is done with this command, FFT. But this is to shift in equal halves your frequency response into equal halves. This FFT shift, this doesn't calculate your Fourier transform. Fourier transform is calculated by this.
No, the inside shift there is Fourier transform.
Inside shift, yes. This one, yes.
Yeah.
Yes.
It do this. It's do the Fourier transform into 2 parts around 0.
Yes, yes, exactly.
Okay.
Then X will give you the amplitude. Okay, right?
Okay.
So now this figure represents the amplitude modulation with a carrier and suppressed carrier. Here this is amplitude modulation, but you can see the carrier is here. Today in this lab we are doing the amplitude modulation with suppressed carrier. At the output there will be no carrier. Will be vanished. So you will get this left side band and then this will be the upper side. Okay. So this is actually this is double sideband suppressed carrier modulation. What happens is you have your message signal. Okay, you have your modulator. Okay, in this case under root 2 cosine of 2 pi FCT. Okay, this is multiplier. Can you tell me what is x of t? X of t? Yes. M of t multiplied by modulator. This will be my modulated signal. And then this is the channel. Here I will transmit this signal. And then this is the output. I got x of t here. Y of t is equal to x of t. I got same this signal multiplied by this. I got here. Then I will again multiply it with this carrier frequency. This is actually demodulator. This is modulator, this is demodulator. And
What
then
is the square root of 2?
this is your carrier signal, carrier wave,
Okay.
carrier signal. So then you will pass it from low pass filter, and then it will remove the carrier frequency. It will just give you the actual information, which you send here, you will receive here. Okay. So now this is the same thing here. Same, I was asking you what is this? M of t, my message, and then this is my, so AC is equals to square root of 2. Okay, so it's here. So this is the amplitude of this carrier signal, cosine wave. Then y of t. So m of t into AC cosine of 2 pi f t. Now I will, what happens here? Now this is your y of t, right? Now this will be multiplied with this one. AC cosine of 2 pi FCD. Okay, what it will be now? MT multiplied by AC square into cosine square of 2 pi FCD. Right? So do you
That's
know
why
this?
we multiply it.
Because this is the process. This is the process of modulation. You cannot transmit your actual signal directly, because then you will not get the actual information at the output. You have to multiply it with some carrier so that your information is not lost.
Always like this.
Always like this.
Okay.
You receive your signals at your mobile phone. How they are coming? Always they are signals are sent on a carrier frequency. You don't get your signal directly. So there is a carrier frequency always involved, so that your actual information is not lost. Okay. So then you know that cosine square of,
Half cosine
yes,
plus half.
yes, I think it's 1 plus 1 plus cosine of 2. This is, if it is alpha, then 2 alpha divided by 2. Yes,
Cosine.
this is right, I think. So this will be m of t multiplied by AC square into 1 plus cosine of 2 multiplied by 2, 4 pi FCD divided by 2. Think. So, okay, so it's here. So this is, by applying this trigonometric identity, you receive this final output. Okay, this is your signal V of t. Here, you had your y of t, then you multiplied it with this. So you multiplied it with demodulator, again carrier frequency, and then you passed it from low pass filter, and then at the output you receive this. Then you can see that this is lost now. This is removed now. Okay, this was our carrier. This is removed, and then your actual signal is here. Right?
This is removed by
Low pass filter. Low pass.
because it's now high frequency.
Yes, this is the low pass. It is removed because it had the constant frequency. So I will apply the filter exactly the same as carrier frequency. This will be removed, and then your message signal will be. So now this is time domain message signal. This is message signal in frequency domain. This is the modulated signal. This is the modulated signal in frequency domain. So this is V of t here. This one. At t, this is at the sending side. This is the receiving side. Receiving. This is sending. Okay. Here, this is V of t. Time domain. This is V of x. This is frequency domain of this signal. This one. Then this is M of t, received signal. Then this is M of x, frequency analysis of
It's all for same signal, right? One signal.
This was one signal.
Carrier and
No. So this is actual message signal, then I multiplied it with carrier, and then this became some modulated signal after carrier multiplication. So this is at the receiving end after multiplication with the demodulator, and then this is your received signal. Okay. Carrier is not there. There is no carrier, but you get multiplied with carrier, modulated signal. There is no carrier. So now today in this lab, we will only do this part. Message signal, we will multiply it with carrier. So what we will do in this lab, we will generate a message signal, and then we will generate a carrier signal. We will multiply them, message multiply with carrier, and then we will plot the time domain and frequency. That's it. And this we will do in the next lab. Okay? Only this today lab is very easy. Okay. So how you will generate your message signal, how you will generate your carrier signal, you will learn it today. So we have this example. Use the MATLAB to generate BS3 double sideband suppressed carrier amplitude modulated signal. The carrier frequency FC is 154,000 Hz. Sampling frequency is 100 times. Fs is equals to 100 times mean multiply carrier frequency Fc, which is equal to 154,000. Then the frequency of the signal is 10% of the carrier frequency. So Fm is equals to Fc divided by 10% of this. And then amplitude A is equals to 10. All the information is here. Someone was asking me the question about this.
I want to ask a question about FM.
You asked about this question. About this. This is last. There was a scale. There was a scale, and then you asked me, can I do the values randomly? Then I told you no, because you will have the values in your question, and then you cannot put randomly. You will use these values, which I will give in. Yes.
Compare kilohertz or
No, it's not needed, because carrier frequency will be always, it will be high frequency.
Miss, the FM is the frequency.
Sorry.
The FM is the frequency.
FM is the frequency of message signal. Message. There are
It's
two.
same as the amplitude.
What amplitude?
A equal 10.
This is you know this. For example, this is a wave. Frequency means this is
Okay.
frequency. This is amplitude.
Yes, I know. But in the question, amplitude given 10. Right. Okay.
Given
Yeah.
here.
Okay.
So then show the message signal. First, message signal we will create, then the carrier signal and the transmitted signal. Okay. In the time domain, show 4 cycles. Number of cycles should be 4. Okay. Then the next step is represent the signal in the frequency domain. Same message signal, carrier signal, and the transmitted signal. 3 signals. Okay. So now FC is the carrier frequency. It was given 154,000. Yes. Then FM is equal to FC divided by 10 because it was 10% of your carrier frequency, right? Then sampling frequency is 10 times the carrier frequency. This was all given in the question. Then yes, this scale I was asking. So 0, 1 divided by Fs. This is the sampling frequency. So this one. Always begin from 0. Always begin from 0. Yes. And then remember these points. Always you will define here and then you will use here. And then
So
4 is,
1 and 4 is constant, right?
sorry?
1 and 4 is always like this, right?
No, 4 is not like 1 divided by fs is same, but 4 is from here. So 4 cycles. I
Okay.
can ask 5 also, then you will change this. 4 to 5.
And 0, 1 also always like this, right?
1 divided by. This is the interval between increment. 1 divided by fs. So this is time, you know that. Sampling time, Ts is equal to 1 divided by fs. You know this. This is increment time. You know this. Okay? So please start writing this. And then I will.
Can I see the question?
Miss,
Yes,
Miss,
yes.
can I see the chat, please?
What?
The chat.
Ah.
Finish that.
What's your name?
Wal Anisi.
Well, okay.
Because in the work, Miss, I'm sorry.
So what you want to do now? You want to leave the class?
No, I can watch, but I can't come in the college. I can't come because the work.
Okay, and then can you write this code? Can you write this code?
I can see, but I return in the home. I can use the lab.
Okay. So I will anyway upload these slides and then you can take help from this in your assessment.
Okay, thank you, Miss.
Okay. So done. Should I leave another slide?
Miss, you upload this file on Moodle.
Yes, I will.
Now it's uploaded or not?
It's not.
Okay.
I can upload it after some time.
And FC from where? From the question also?
Sorry,
FC from the question?
which one?
The
F-
first line, FC.
Carrier frequency, yes. FC means carrier frequency. M is message, C is carrier. So this is given here.
Where?
See? This is carrier frequency signal. Can you see my mouse?
Yeah.
This carrier frequency signal is 154.
Kilohertz. We multiply by 1000.
Yeah, K means 1000.
Okay.
K is 1000. So you see here 154,000. Okay. So this is clear to all of you? It's here. So this is easy. If you see the question, try to analyze the question, then you can do it.
Is that number correct?
Which one? You have not been.
Okay.
Only your code is this.
I know, but you write other examples of other ways that I can write
Yeah,
it,
yeah,
so
yeah.
I was checking.
Actually, this is 154. 154 multiplied by 1000. It's not 451. There's a mistake. Yes.
I finished like
All of it. All of it. Until here.
yeah.
Yes, I will go on. Yes, also, please. This one? Okay, I can upload. I will upload it. This will, you will need it for solving your assessment. I will. I already extended the date also. You asked me?
Yeah, the last time.
Mm. I will upload after this lecture immediately. So then, this amplitude was given, you remember 10 in the question. And then what is this? So
Yeah.
this is my
Carry.
C for carrier, M for message. So this is message signal. The message signal has an amplitude of 10. Go back. See here. The frequency of message signal is 10% of the carrier, and the amplitude of message signal is 10, not
How
the
do you
carrier.
know it's a cosine function?
Yeah, cosine.
How do you know that?
This is cosine function. This is always like this.
Even if it's not mentioned in the question.
Even if it's not mentioned in the question, you have to use cosine. Sinusoidal function. So here also cosine. Here also cosine. Okay. This is the message signal. Then, if there is no amplitude for the carrier, how much is the amplitude? 1. So, cosine of 2 pi fc. Here you will write the frequency of the message signal. Here you will write the frequency of the carrier signal. And then, what is this? This is message signal M multiplied with C. You remember this one? So this was XM, XC, and then this was Y. X multiplied by XM multiplied by XC. You remember? So this 3 commands, 4 actually. A out.
Miss? Miss?
But this time here it was not mentioned. If it is not mentioned, then then you will use that. Yes. If it is mentioned, then you will use that. So maybe I can mention the carrier signal of this. Then you will use exact that.
Miss?
Yes, but it's fine. You have your vector. Here you will get your plot. But not now. I didn't do it. Yes.
Miss, this the M, it's not given in the question. We memorize it like this.
If there is no signal, then you will consider it as a sinusoidal signal. Okay? I can use
Sinusoidal.
sinusoidal. This cosine is sinusoidal function. If it is not mentioned, you see in this question there is no. It's not mentioned. Okay, your M is equals to signal is something 1 divided by 2, maybe sine of something. It's not mentioned.
Yes.
So I put it by default cosine. Okay.
On the C.
Yes, the for the C same. I consider that I suppose this is sinusoidal function. But if it is mentioned, for example, if I mention something in the question, okay, your message signal is this, your carrier signal is this, then you will use that signal. But here it
It's
was
not mentioned. I write this two equation.
not exactly these two equations, but with these. You should know that how you define these FM and FC.
Can I share? I finish.
Okay. Yes. Yes. Yes, we will plot
Here
it.
two. Here two, right?
2 pi. Because
2
this
pi.
is omega naught, and this is the cosine of omega naught of t. Omega naught is 2 pi f.
Okay.
Yes. So,
Stop share.
yes. Now just plotting. So here, just write this one, not these two. Okay. And these are only the labels. Then plot this, and then this. 3 signals. Okay. What? Like, I was thinking you can't see the keyboard. That's why I turned the light. Yeah, you can't see the keyboard. Yes. Then this light goes. She has problem. Okay, should I turn the light on again? Okay. So just write these three commands. This, and this three. Okay. And then this is not necessary. Now. All of you got three figures?
Yes.
This is X. Huh? You understand this?
Yeah.
Labels is not necessary. No error.
Yeah.
Not necessary. Yeah. And then third is
No. Yes.
you're solving your assessment also. Good. Is it easy? So now this is all time domain, right? Now what was the second question? Frequency, yes. All three
Yes.
signals.
Yes.
Yes.
Wait here in the blot. The blot T here, the first one time carrier, right?
Mm-hmm.
Then
Yes.
time frequency. The
No, no.
XT was
No, first time carrier. Yes.
the
Time
second.
message. And
And
then modulated signal.
The third one, what?
Modulated signal. Last one. When you
Okay.
multiplied carrier with message, you got x of t. You stored it in x of t. You remember?
Yes.
Here. This xt is this. Right?
Yeah.
Okay. You got three plots, right? me what should I do for the frequency? What should I do to transform it in frequency domain? Fourier, FFT. Yes. So I will take FFT of my message. So first, this you will distribute the scale. Okay, now your final signal is x of t here. Okay. So my n will be, number of samples will be up till length of x of t. Okay, this. Then length space minus fs divided by 2, fs divided by 2, and then n, total number of samples. This one. Right? You remember what this length space is doing? Equally spaced scale. Then I will take FFT of, so these are three commands here. So one is for message, one is for carrier, one is for my modulated signal. This is total number of samples, this one, and then normalized with total number of samples. Okay, and then FFT shift, you know what is it, and then absolute. Done. And then after this, simple plotting. Right? Clear?
Yes, I have a question on the assessment.
Yes, assessment.
I'm trying to solve,
Uh-huh.
and I solved the example in the lab form.
Which one?
The question you same this you give it to us.
Yes.
You want me to share screen?
Okay, but assessment I will not solve now. Okay, here. Go up. So, yes, this is almost the same. This is example.
Example.
Hmm.
The assessment, I have a question here. The 8%.
Of the carrier frequency.
Yeah, I put the FC 200. Then here I divided by 8 FC.
Yes.
It's 8%. The FM equal FC divided by 8.
Yes.
The number of cycle I put 5.
Is it 5 in the question? Because I didn't review it. It's 5?
Yes,
Yes.
5.
Yes, 5. The
And
number
what
of
is this 100? This is what?
sampling frequency. Fs is equals to 100 multiplied by Fc. Fc is equals to 200,000. 100 multiplied. Yes, so you wrote it correctly. Yes, correct. Yeah, it's here. And
Here?
the three, line number 3. Line number 3. Yeah, this. This is your sampling frequency.
So this right, like this, right?
Yes.
And the equation right, like this M equal A cosine 2.
Because signal is not given. Okay. Yes. Yes.
Okay.
Subplot you don't need.
Subplot I don't need.
No, you don't need. Because you are working with MLX. So you don't need.
Only plot, I remove this.
Only plot, yes. Also put the labels and all the
title.
Title, label, X label, Y label. This is
Like
time
this?
limit. Yes. Now there are 3 kilos.
Right?
Yes.
Okay, thank you, miss.
So, okay. next step is only the plotting. Yes, you have to expand the scale. So expand you can expand the scale with this because it's narrow. In your case, if you directly plot, it's narrow. Now you will expand it across this. So this you have to write so that you can get clear after the plot. You see, the first plot is here, and then after this, axis. Then the second plot is here. Your answer is correct, but this is string.
Can you go back?
Okay. Here. What happened? You can't go back and go out? Why? Really, we are locked inside? I don't know how to go out. We are locked inside. Really? I asked. Yes, we are locked inside. I don't know.
Okay.
Something recent.
Nothing is Is my guard? Which one? I don't know. Who loved this? That was black. Change it. I don't know. Call the security. We are locked inside. Maybe there is some way to go out. Ah, yes, there is. So. So now we're done.
So 40 plus 2 is only 40.
So yeah.
Should I include the rest of the- So I will collect the
شفت لك ثلاثة المشروع شو هذا السنة ولا هي تأتي بالإكزام هو يطلب شو السنة برد أفراد بالإكزام إيه صح أبغى أكتب الإكزام بس أكتبه على أحللها بس المشكلة مين؟ يعني لو سألني شنو إجابة واي بس سالب 3 يعني بدل سالب 2 هو على بالي أنا أقصد بس سالب 2 مو واي بس سالب 2 يعني أنت بقى أنا ما تشوف
Yes.
Yeah, I will do the same thing for the career. This is signal we call it also modulation.
Message it is written here. I will upload it.
Yeah.
So you don't want to go out? Done? So, you are asking about if you show the comment this, that right? Now you can't see where it is ending, so that's why I chose this case from see this temperature 1.5 and chose 0.6 so that I can see the maximum. George, this is the figure. You see now. You can according to the figure, you will see it, and then you will. Yes, sir, because you use subplot. If you don't need to do subplot.
If I remove it, will I get the same?
Yeah, no, you will not get the same. You will get 3 different figures. Yes. A bit difficult. This one, remove. Where's the third one? Now you will get 3 different figures.
Yes,
Yes.
I have questions.
Clear. Yes.
Can I share my screen? I will show you in the solution.
Yes.
Here I solve it. I have a question here. The plot. First, they want the message signal, right?
Message signal. Yes.
Where is it here in the this one?
So what is the message signal?
Is
First
this
of all-
plot TC?
C is carrier.
C
You see,
carrier.
S is for message, C for carrier, and then
This message signal.
yeah, message signal. Yes.
And this is carrier.
C. Yes, this is
Then
carrier.
this is
Yeah, which one?
the last one is the transmitted signal.
Yes, modulated signal. Modulated.
Then what we write the shifts. Then we plot again what we plotted. This is in the question where.
So sorry. Okay. So now you see, I explain you. So first is your message. Okay, you have a message, right?
Yes.
Okay. You want to transmit it, right? You want to send
Yep.
your message to me. If you're standing far away from me, if you send your message directly to me, there is air, right? Your message will be
Yes.
lost. What you will do in communication of electromagnetic signals, what they do is they multiply it with the carrier frequency, carrier signal, and then they transmit. And then at the receiving end, there is no loss of information. So this is happening in communication. So you are also doing this. You are having you got a message signal, then you define a carrier signal, and then you multiply both them together and then plot. In this figure, we are just doing this. We are not doing any thing at the receiving end, only sending.
I understand, but why we plot again here? This is the second
yeah.
one, this one.
Yeah. Okay. Okay. So first is time domain. If you see in the question, first is time domain. The second
Time
is
domain.
Yes.
A frequency
Second
domain.
frequency domain. That's why I plotted 2 times.
This is in the frequency domain.
This frequency domain.
And what is this? The axis is
Okay. So if you don't put the axis here in the students who are here on site, they plotted without the axis. What happened is the figures were not clear. If you comment this axis, you will. If you comment this and then just plot FC. So
it's
okay,
always like this coming.
no.
I
it's not.
memorize it.
No.
I don't know how to write it.
I tell you. Wait a minute. So
And
here.
in okay.
Okay. I can write here also in this window. So
Okay.
I want plot of FC. Just run this. You will get a figure.
Miss, can you close?
I plotted up your figure. So where is the figure?
Close this.
What? You got
Yes,
another?
the small box.
Which box? I don't know.
Yeah, it's gone. It's gone.
So you see, there is a figure, right?
Yes.
I plotted FC. So I
Yes.
couldn't get the figure. Where is the figure? Can you show me the figure?
Figure what?
I plot FC.
Yes.
And then just remove these. You don't need because I want a clear plot.
Yes, I think you need to share the plot because this is command, right?
In the command also, if I write plot something, then I think he's not sharing his full screen.
I'm sharing.
See that you should share again.
Yeah, I think he's not sharing his full screen.
He's on it.
Yeah, it's not me.
Sorry,
It's him.
sorry, I thought it was he.
I am doing in his. Okay, so I think he's not sharing full screen anyway. So you will get 3. Yes. And also write the comments. What is that? So is this running or not? Did I run?
It's running. Finish, Miss.
Okay, so why I am getting again this? This should be 3 figures. Now there is only 1 figure.
Yeah, because there is subplot here.
No, there is no subplot. Where is subplot?
Up.
Okay, remove that. Actually, this is not plotting your frequency spectrum. I don't know why, for some reason. So let me fix your problem. I can't control your screen. So until here, this was, there is star. Until here, this was time domain.
Okay.
And now this is all frequency domain from here. Okay. So first, let's see, because in your case this is not running. There is some problem with your plot. Let's see. This is carrier. Okay. Now yes. Now this is running correctly.
Yes, Miss.
Now I tell you about the axis now. Okay. If I
For
comment.
the frequency domain, I must write the shifts.
Yes, that is important because you see, the zero frequency component is shifted to 0, and then you have on the both side you have the frequency domain spectrum.
Okay.
Okay, so you see, I commented your axis. Now I will plot your FC. Okay, where is your carrier? This one. This is
Okay.
your carrier. Okay, if I run it, so you see. Okay, now you can't see anything.
Yes.
Yes, you can't see. Here you don't know how much is the amplitude. Your amplitude is lost. So what you do is you separated it equally with -2 FM and from here to here, and then 0, and then 0.6 is the amplitude. You will see 0.6, then
From where
0.6
the numbers I bring?
from here, from the figure. So you see, this is 0.4 here, right? And then your amplitude is going above 0.4. So, okay, let's see. I can choose 0.7. 0.7 also. See. Now my amplitude will be clear. It's not necessary, but now this is.
So, Miss,
So,
first we plot, then we find the numbers.
yeah, from here, from the plot. First you will plot, and for the x, you will find the numbers from the figure. Okay.
Okay.
If your amplitude is going away, you should, like, from your own knowledge, from your own understanding, try to fix it so that full figure is clear.
And why the second one, 1 plus a divided
Yeah.
by 2?
So you see, amplitude is how much? 10 divided by 2 is 5 plus 1, 6. So if I just choose it, because you remember the amplitude of the message signal was 10, right? It was 10. So if
Yeah, it
you
was 10.
just 10, control V. So if you remove this, just run it. So exactly it will match here. So now this.
Okay.
So you want it a bit higher, a bit higher. So now this will give you a bit. Now this is clear.
Why here without amplitude with the 0.6?
Where?
With the 0.6, the first one.
Yeah, because you see your figure. Okay, this is 0. I removed it, right? I removed it. I showed you. Percent. I removed it. With percent, I removed it. Now run your code. See the figure now. So this is going above, and then the maximum point is 0.4. Okay. Now I will choose some point so that I can see this amplitude. So that's why I choose 0.6, because now I can see my amplitude. Because I know that my amplitude.
Why we choose -2 and 2?
I choose 2 also, because this is equal distribution of your frequency components.
I can put 1 and 1.
No, you can put FC minus FC to see. Okay, let's check this out. Anything if you want to do. So let's see what we have.
-3 and 3.
No, you have to choose with the frequency also. Because this, now this value must be 1 into 2 by 4. So you have to multiply it with some value. This is not possible in MATLAB.
Always multiply with 2.
Not 2, you can do 3 also, but some amplitude.
But what?
Some value. You can choose some value greater than 1. Some value greater than 1. You can come to me. I didn't have a meeting with you, but I did take one day. At least take one day. Because first question was very easy. The second is thinking. You can do it. So, okay, everything is clear? Done?
The last
So,
one.
so- yes. Yes.
The last one.
Which last one?
0
Okay.
and
So,
3.
yes, I wrote 3. Because if you remove this, again, just in MATLAB, nothing is permanent. You can remove everything to check, okay, what is happening if I remove this. So the last one is here. Now what is, nothing is clear, but the amplitude is clear, right? So I
Yeah.
choose the amplitude exactly 3.
From 0 to 3.
0 to 3. And then the same, -2 FC.
Miss, in the assessment, I do the same.
Yes, yes.
I plot again and I do the shift in the assessment.
Just plot and then you will choose the axis, look at the figure and then choose the axis so that the graph is clear.
Okay.
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 So how many students are okay, I'll stop your screen. How many students are here? Okay, so this is section number 1, right? I want to take the attendance for today. So Reem is present. Reem,
Yes.
okay. Yusuf, absent. Okay. Basim Safaq. Yes, Ila. Fatima Ahmad. Absent. Anwar. Muhammad Ali Muhammad. You. Okay. Abdul Mansoor. Abdul Mansoor. Abdullah. Abdullah Mansoor. Absent. Okay. Dari Muhammad. Dari Muhammad is here. Okay. Then Asma Abdullah. Arij. Okay. Taiba. I think Taiba has to go somewhere.
Since you call my name.
No, not yet. So Nawal. Okay. So Taiba I marked absent. Hiba.
Yes,
Hiba
miss.
Abdullah. It's you, this one.
Yes.
Okay. Fatima Yaqub.
Yes.
Khadija Fawaz.
Fawaz here.
Okay. Taiba Joda. Abdullah Abu.
Yes. 191397.
Yes. It's difficult your name. M Sarah. Miss
Msira.
Miss
Yes.
Sarah.
Miss with you.
Yes. Okay. Fatima Fahad.
Yes, yes, with you, doctor.
I think he was here.
Yes, miss. Yes, miss.
Yes. Abdul Hadi. Abdul Basit. Ahmad Said.
Yes.
Okay. And Amina. Yes, present. Okay. So Taiba has done a lot of absence. So, okay, now today is over. So assessment is there on the Moodle. Try to solve it and then
Yes,
ask me any questions.
I have a question in assessment. I write the
Yes.
Thank you, Miss.
the reminding question.
Yes. Okay.
But I have the same solution. How?
Show me where. It will be almost the same because question is almost the same. There will be minor
I cannot
difference.
share.
Okay, you can see the scale. There will be minor change in the scaling.
Same.
Okay, go up.
Only the first one different.
Yes, because the cosine, your sinusoidal signal is same. There will be
So
minor.
this is right.
Yes, this is right. So there will be minor difference in the scale.
No difference. Same.
I can see it later because I didn't solve the assessment myself also.
I can come to university.
When you want to come? Because I will solve it myself also. Today I will solve and then.
And this question I didn't understand.
Yes, you have to take reference from the previous question. You see that there are figures and you know what is the frequency of the previous question. You know it. So using the reference of the previous question, you can try to figure it out. If you are not able, then I will help you. But first think about it.
Okay. Tomorrow I have classes at campus.
Okay, so tell me when you will come to me, my office. Because I have a class from 1 to 2.
In the morning I don't have a class.
Okay, in the morning come to my office.
From 9 to 11.
Okay.
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 Thank you.
Thank you. Bye bye.
Can you check for me just for us?
Okay. So I leave the meeting from here.